In terms of network security, we can group this broadly into two different categories: on-premise security and cloud-based security. On-premise refers to the fact that our environment is physically present on the premises of our business. We need to have an awareness of common threats to both types of these environments and to be able to differentiate between those. And we do that by knowing their individual characteristics, starting here with on-premise threats. First, let's discuss the term malware. This is a catch-all term used to describe malicious software. Many use this word interchangeably with the term virus, but this isn't exactly correct. A computer virus is actually a type of malware. There are many categories, including, but not limited to, spyware, adware, ransomware, and of course, viruses. A virus typically requires some sort of human interaction, so they depend on people to spread them. This can be any action ranging from opening an email attachment to clicking an executable file. This is the unique characteristic of a virus, the fact that it typically requires some sort of file or program to infect with human intervention involved. All viruses have search and infection routines. The search routine is tasked with locating new things to infect, which could be files, hard drive space, or RAM. After the search routine, the infection routine is responsible for multiplying the virus and attaching it to the vulnerable items found with the search routine. Many viruses will also contain a payload, specifically a malicious payload designed to do harm to a victim's computer by things such as altering or deleting files, among other things. More advanced and more modern threats also contain anti-detection routines. Some examples of this include the ability to intercept and suppress warning messages from the operating system or from the antivirus system, and the ability to modify itself and change the underlying code for stealth. Trojans are a type of threat that disguise themselves as an innocent or legitimate item, but when they're executed, they download or install harmful malware onto a device. In contrast to viruses, Trojans do not self-replicate, even with human interaction. That's not the goal of a Trojan. The goal is to simply be disguised as a harmless program or file in order to trick the user into interacting so that the Trojan can open the system up to a litany of threats. Trojans can download additional malware or come bundled with malware ready to install. Examples of Trojan actions include installing backdoor remote access, disabling firewalls or antivirus systems, or using key logging to obtain passwords, credit card data, and other sensitive information. We also have denial of service and distributed denial of service, also known as DOS and DDoS attacks. These attacks are specifically designed to disrupt or completely disable a network by flooding them with unwanted traffic. There are many ways that this is typically accomplished, and one of the common ways is through an ICMP ping flood attack, where an attacker would try to overwhelm a target with echo request packets. DOS attacks involve a single attacking system, while DDoS attacks use multiple systems working together to attack. Today, we most commonly see DDoS attacks using botnets. Botnets are a group of devices all infected by malware in order to allow an attacker to take them under their control. Phishing attacks are used to steal user data such as login credentials or financial information, and they leverage social engineering. Most commonly, we see this played out through phishing emails, using spoofed email addresses and messages that appear to be legitimate. A common tactic for this is to send a legitimate-looking password reset email requesting a user to update their password. Upon clicking the link, the user would be redirected to a spoofed web page that is under the attacker's control, and this gives them access to any credentials that would be entered here by the user. A rootkit is a threat designed to provide privileged access to a system while remaining hidden, as opposed to some threats such as viruses or spyware, which can cause very visible issues. The goal of a rootkit is to remain quietly in the background, allowing an attacker to obtain remote access or control of a system. These are difficult to detect because of their ability to bypass security software. And although there are ways to detect rootkits, they are especially hard to remove. In fact, the only option for removal in many cases is to completely wipe and reinstall the operating system. Rootkits can be delivered through many ways, such as Trojans or phishing attempts. Man-in-the-middle attacks are also well known. This is where an attacker will position themselves logically between a user and a destination resource. You can think of this essentially as eavesdropping on a user, and there are many iterations of man-in-the-middle attacks, from rogue access points to DNS spoofing. The main characteristic here is that an attacker is intercepting victim communications in some way, whether that's wireless traffic, DNS resolution in order to redirect a browser, or stealing browser cookies. Then we have SQL injection attacks. SQL is the standard language used for accessing and manipulating databases, and SQL injection attacks specifically target database resources such as web applications. If a particular server has a SQL vulnerability, an attacker can inject partial SQL commands into an input field, such as a web application login form, which would cause the database to respond and return unexpected data rather than ignoring the SQL commands. Actions the attacker is able to do can range from simply viewing or modifying private data all the way to deleting the database itself. We can categorize SQL injections into three main categories. First being in-band SQL injection, which is the most basic form of the attack. Here, the data the attacker is retrieving is visible directly in the web application or web page that they are attacking. We also have out-of-band SQL injection, where the attacker would have the results sent back through a different channel, such as an email message, or maybe through copying the data to another remote system. And finally, we have blind SQL injection, where the attacker learns information about the database based on the server's reaction to the injected SQL commands. Even if the server isn't displaying the data itself back to the attacker, a vulnerable server may display SQL errors when the commands are injected, which can reveal certain things about the database itself, such as the structure of the database, the version, and more. And finally, we need to know about cross-site scripting, which you may see listed as XSS. This is another type of injection attack where malicious scripts are injected into trusted sites. Because the websites are trusted, the browser will also inherently trust and execute the harmful script. And these are commonly used to view cookies, session tokens, and other sensitive information stored in the browser that's related to the site in question. We see cross-site scripting attacks as either reflected or persistent attacks. Reflected XSS attacks are typically delivered through phishing emails or search engines. The malicious links themselves would direct a user to a vulnerable server that would inject or reflect the malicious code back to the user's browser. This causes the browser to execute the script and send the browser session information to the attacker. A persistent attack, or a stored XSS attack, involves a case where an attacker is able to permanently store a malicious script onto a server database. In this case, a malicious link isn't required, meaning that every visitor to an affected website would be subject to the malicious code execution. So that's a look at common threats to our on-premise network security.